one thing that I was going to mention, I'm here on site, and I've been working with a few different people who have sort of watched these, and they said, hey, you type these SQL statements and then you delete them. And I'm like, wait, let me see them again. And I've got prep notes for every week, in addition to the PowerPoints that I make, that usually make. I didn't make one this week, but in addition to the PowerPoints I make, I've got all these notes that have just notes to myself, telling me what to say in these lessons and all of the queries, because I tend to, get nervous on these calls and make typos and stuff like that. So if anybody wants my notes, they're not even that raw. I mean, they're a little bit raw. They're all just to do it in Notepad++, but it's basically a bunch of SQL queries and comments about them. So what do you guys think? Do you want me to post those on SharePoint or share them with you or something like that?
Sure.
Okay. So I say for now, anyone who's interested in these raw notes, just as a reference, let me know, and I'll send them over to you. It's just text files. I've actually, I had a problem the other day with some date logic. I got to look up date logic every time, including when I wrote my notes for lesson 1 of this class. And I was like, oh, I already solved this problem. So I went and found it and used it and saved me like 10 minutes of Googling around. So it was nice. So maybe it will be handy for you. All right, so today we're going to talk about aggregates, so counting data, summing data, getting averages, and what kind of cool stuff you can do with aggregates. I chose to focus on aggregates after joins because I think joins are harder. Joins are, take more time to sort of settle in. And so I figured I'd start with that hard stuff first and then have a nice relaxing time with counting and summing. I will probably revisit joins today with some of my count examples. So that's another reason why it was important for me to cover joins first. I have about 5 or 6 pages of notes here that I'm going to go on, and like with joins, I got like halfway through my lecture and realized that I was barely done and needed to review this, so we might do the same with this, but maybe not because it's a little easier. So anyway, without further ado, just a reminder of our students table and my fake data. By the way, so far Javed and Sudan have loaded my fake data and have this accessible to them. So if anyone needs help with this, I know we went over this in last week's course, or the course 2 weeks ago, but feel free to reach out to me too, or Sudan or Javed, if you need any help loading this fake data, installing SQL and stuff. All right, so we look at our students table. We can select star from students. So that's great. I've got all of my students here, and I see that I have 81,458 records. But instead of just selecting star and seeing all of my records and seeing this number here, I can do select count star from students and get that same number here. So this is just a count of every single record in my student's record. And that's it. Thanks, everyone. Just kidding.
You're funny.
So, thank you. One thing I meant to say at the top is some of these examples are going to be sort of dumb, but I want to get you guys all into the syntax, familiar with that. And then at the end of this lecture, I'm going to show a couple of real-world examples that you might, if you have any live SQL access now, that you might be able to use immediately, such as finding duplicate records and stuff like that. So cool stuff eventually. Now, so I've got select count star by students. Having some monitor issues, so I actually printed out my notes and I'm looking at them, so excuse me if yes, here we go. Okay, so we've got count.
Mike,
I'm going to talk about math.
excuse me, would you increase your font just a little bit bigger, please?
Oh, sure. Yeah, absolutely. Let me hide this. What does that look like?
Much
a little
better.
more? Much better? Okay.
Yes. Yeah.
Cool.
Thank you.
Yeah, happy to do it. All right, cool. So if I go back to select star from students, I could do something like this. Select star from students, order by last name descending. This is stuff I covered in week 1, and I get the most recent, or the highest in the alphabet last name. So I'm ordering by last name, descending. I can also say order by last name, either ascending, or just leave that ascending blank, because that's the default sort order. So lowest to highest, and so I get the lowest in the alphabet. Now, instead of doing this, if I want to, I can say, give me just the highest in the alphabet last name. So I can say select max last name from students. And I get the highest in the alphabet last name. I can also say select min last name from students. I get the highest last name and the lowest last name alphabetically. The same works for date of birth. Go back to just the star. So if I want to say, give me the oldest person, these little pop-ups are too much. If I want to find the oldest person in my record, in my database, select min DOB from students. 1900, all right. And if I want to find the youngest person, I'd say select max DOB from students. And that is a very young person. Okay. So, again, these aren't necessarily the most salient examples in the world, but I just want you to be aware of the syntax of these things and see them. Just one more thing, I can do something like, this is not very interesting, but again, I can run max on anything. Dates, numbers, pieces of text. If I do a number, it just takes lowest number, min, highest number, max. If I do on text, it's alphabetical. If I do it on date, it's in date order. It's pretty straightforward stuff, min and max, and we did count. Now, one pitfall here with min and max, if I did something like select max first name, max last name from students. Well, I got some crummy data in here, but anyway, that's the highest alphabetically student name, Z, 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 and then Zygmunt, the highest alphabetically last name. If I run this like this, and I see a row here, so let me just give these columns some aliases so it's easier to look at. Highest first name, highest last name. This row to me suggests, oh, this is a student. There's a student named ZZZZZZZZ Zygmunt, and that is false. And it might look pretty obvious and easily avoidable in this example, but this is something that will come up from time to time. So this isn't a student. This is the max first name in my table and my max last name in my table. But other than both being maxes, these have nothing to do with each other. And to prove that, I will say select star from students where first name equals, and then I'm going to do a little subquery here. I could just type ZZZZZ like this, or that's fine. Or I could say select star from students where first name equals, select max first name from students. And so now I'm saying, give me my one student record where the first name is the highest alphabetical first name in my students table. And I can basically, I'm just going to copy and paste this because I'm lazy, and say, let's do the same thing for last name. And run this. So again, my student with the first name bunch of Z's is a Mr. or Mrs. Barth, and then my student with the last name of Zygmunt is Christina. And again, that proves that if I run this, Mac's first name, Mac's last name, this is not a student. These are two separate names that have nothing to do with each other. Just putting that out there because this is something that's bit me before in my early days of SQL playing with. All right. Now, so far, I'm erasing this, but remember, these are all in my notes, so ask for my notes if you want them. So far, I've managed to get counts, mins, maxes, but I've only asked things like, give me the count of all of the students. But what if I wanted a count of students by last name? Like, what if I wanted to know how many Jones there were, how many Smiths there were, etc.? So let's try that. So before I was saying select count star from students, and I was getting a number. But with just a few little changes, I could say select last name count star from students, and this should give me the last name and then the number of students with that last name. Almost. So I'm going to talk about this a little bit, but when you do something like this, when you have a non-aggregate, so this is just a regular piece of data mixed with an aggregate, you have to add a little piece of syntax introducing group by last name. And this is just a little, sorry about that, this is just a little extra hint to tell SQL what we're counting by. It's not enough to have it in the select clause. You have to have it in the group clause. So just, I'll talk a little bit more about the theory of this and give you an absurd example, which will hopefully cause this concept to make sense. But if nothing else, just remember any non-aggregate thing in your list of fields in select has to be reflected in group. So what this is showing me is all of my last names. So there are 3 people with the last name of Firemoon. That's awesome. I can give this an alias. Fairly impractical alias, but just so you know. And then I can even order by. So I can say order by count star. I can actually do a number of things here. I can say order by count star descending. I could say order by this whole alias thing descending if I wanted to. Gives me the same results. I can even say order by 2 because it's the second item in my select list. Last name is 1, count star is 2. Whatever I want to do. I can prove that my most common name is Johnson, followed by Anderson, followed by Smith, followed by Miller, followed by Jones. This is actually derived from real data, so this is interesting. But yep, these are our most common names. And yes, okay. So the reason this is important, I'm going to make a smaller data set here. Let's add a where clause here. So if you remember where clauses, they're still a thing here. I'll get rid of this. Oh, I'll keep that here. But I can add a where clause, and let's do something like, let's take some of our most common names just in general, if not in my table. Smith, Jones, Patel, Wynn, Garcia.
Kazrabadi.
You're right.
You know, mine's pretty low on that list as well. Let's see how mine. Whoa, there's 8 Carmens. That's crazy. It must be because I built it. I mean, next time I'll get you represented in there. Anyway, there's probably this many Carmens in the world, as far as I've been able to find. Yeah, so I'm reducing it down. So 427 Smiths in my table, 341 Joneses. Now let's say, again, this is an absurd example, and you might ask while I'm covering this, why would anyone ever do this? But when you're off in the real world doing real SQL, you are going to, I guarantee you're going to accidentally do this all of the time, and you're getting an error, and you're going to say, what the heck am I missing here? So I'm demonstrating this with a very simple example. Just know that this is a real thing, and if you know to look for this, then it's going to save you hours of head-scratching and troubleshooting. So if I run this, does anyone see anything wrong with this query? If anyone wants to, I just want to give someone the opportunity to tell me what's wrong. No. Where's what comma? Sorry, not no. What comma? Thanks, Ben, for talking, by the way. Even though you're wrong. Thank you.
Yeah, now looking at it.
Goodbye, everyone.
Is it not knowing whether to count the last name or the first name?
That's actually, yes. Basically, yeah, that's right. If I run this, I'm going to get an error. And it's going to say column students.firstname is invalid in the select list because it is not contained in either an aggregate function or group by clause. So really what it's meaning is, as I mentioned before, any non-aggregate field up here in the select list needs to be represented by group by. Because if we look at this data here, I got 427 Smiths, 341 Jones, 91 Garcias, etc. If I asked for first name, SQL's really, if it spoke English, it would say which first name. You got 427 Smiths. Which first name do you want? So because I'm not grouping by first name, it gets confused and it doesn't know what to do. If I add first name here, I have to add first name here. And the results are very different, as you'll see. Now I'm saying take every combination of a last name and a first name, where last name is in one of these items, and give me the number of students there. So, what is that, 711 rows? Okay. Looking at my notes here, sorry. There's a point to all this. Okay. This is where it gets interesting. So I'm looking for, give me a last name, first name of students, and give me the count. Group by last name, first name. And now I know the number of students with that last name. Let's just make this column alias ridiculous. Maybe there's a limit here that we'll find.
A question.
Yes.
How come they're ordered by Zachary, by their first name? Because
I say order by 2.
So
this is a nice shorthand. This is funny. This is a really good question. This is a convenient shorthand because what this says is it just says order by the second column. Before I added first name to the mix, I was ordering by this column, and that's what I intended to do. But when I added a column in the middle, that messed this up. So actually, my personal preference is just to order by the specific thing. If I'm wanting order by account, or order by this alias or whatever, always, no matter how many extra columns I put in here, I do that. See how much less typing it is to type in just a number? But again, I didn't intend to order by first name, so thank you for bringing that up. So that's why I like to just type it all out longhand, always. So now I have 7 Sarah Smiths, 6 Samantha Smiths, 6 Michael Jones, etc. And I've got 711 rows here, like before. And I go down, and I can see all of my unique names here. There's no other Grant Garcia, etc., or E. Ill, wherever that data came from. But now, if I want to do something like find all of my duplicate records, now last name, first name isn't really good duplicate criteria, but we're going to get there, trust me. I'm going to introduce another piece of syntax. So here in my where clause, I'm filtering out all of these records by only people with these last names. if I were to, say, comment this out, instead of 711 rows, I would get quite a few more, 78,000. This is all of my students, regardless of what their last name. So I'm filtering it out just because I'm only interested in these 6 last names for whatever reason. Keep the data smaller, keep the query smaller for now. Where effects filters is pertaining to from. So I'm limiting my data with this where clause. I can do the same thing, but only these non-aggregated fields. So I can do the same thing under group using a term called having. Having count star greater than 1. So having is to group as where is to select from or whatever. Having is groups where, however you want to mention it. When you want a where clause to operate on these aggregate functions, it has to go into the having clause. So just to put a fine point on that, I couldn't say where last name in these last names and count star is greater than 1. That would give me a syntax error. And that's basically because, not to get too far into the weeds, when SQL runs this query, it gathers all of this data together, and then once it's gathered it all and filtered it all and everything like that with the where clause, it groups it all up. Only once it's grouped it can it say, okay, now we can filter it even further down on this grouping information. So having count star is greater than 1 means give me, see, without the having I had 711 records, but with the having I have 132 records. So these are all non-unique names across the board. And I can go ahead and add fields to reduce my duplex. So this is basically, and every one of you as a higher ed employee has experienced the problem of duplicates, finding duplicates, resolving duplicates, etc. This is the beginning of one way to find duplicates. So let's add some more fields into this, because of course there's 7 Sarah Smiths. That's easy. Of course there's 6 Michael Jones. So let's add middle names into here. So if I say middle name, okay, what am I going to have to do to make this query work?
Put it in the group by.
Thank you. Just so you know, the order here doesn't actually have to match the order here. I just do it because it's easier to read later for me, just FYI. So I run this. So I had 132 rows when I was just looking for first name, last name duplicates. Run this, I'm going to get 48 rows. So, and that's mostly because I got a lot of null middle names. Just to get rid of that null is null. If it's middle name, let's make it blank. And it looks like not a problem there. So a bunch of blank little middle names, a couple of ones that aren't blank here, but that's about it. So these are all of my folks. This is going to be much more interesting in a real database. In fact, let's get rid of this last name stuff so we can get more information, more interesting data. Let's add a where clause and say where middle name is not null. Bam. Okay. This isn't null, it's blank. FYI. But okay, now we have 2 Samantha Langs. That's interesting. We've got 2 Sarah A. Johnsons. Okay, now we're getting closer to sort of a duplicate thing. An actual duplicate query to find duplicate student records in your database. That's cool. We're getting somewhere. So let's go ahead. I'm going to get rid of this where clause. Again, it's all in my notes, so talk to me later. Let's go ahead and add addresses to the mix. So let's say something like, I'm just going to change this to num of students. That was a silly little game. Let's say, give me everyone with a matching last name, middle name, first name, and state. You'd probably want to do even more than this in the real world, but I know what my data looks like. So I'm going to do something that actually gets results and is interesting. So we're going to bring a join into this. This is why I covered joins first. On students.studentID equals addresses.addressID. And let's go ahead and add state to our group by. And now if I run this, I think, yeah, take that away. One person, okay. There is one Brandon Johnson. There are two Brandon Johnsons who live in California. That's suspicious. And I would bring more into it, but I don't actually have that many duplicate records. But if you were to run this on your own database in the real world at your school and started looking at, give me everyone with the same first name, last name, middle name, city, state, birthday, all that common duplicate criteria, you can start finding problems in your database with duplication. And that is a huge value that count and group and having brings, this aggregate stuff brings. So I can go even crazier by doing a subquery and doing all sorts of cool little stuff here. So I'm going to do this. I'm going to just make this. So I'm going to turn this into a table, and I'm going to call this duplicates. So then I'm going to say, so I'm bringing in everything from all of our past lessons now, pretty much. So I'm going to say, let me get the student ID, the first name, the middle name, table name is called students, the last name, the city, even though I'm not using that as my duplicate criteria, I want to know what the city is, addresses.state, from students, join addresses on students.studentID equals addresses.addressID. Join this whole thing. I mentioned this 6 weeks ago now at this point, but you can take a query and treat it like a table. So now I have this table, in quotes, that I've decided to call duplicates. So I'm going to join duplicates on a bunch of things. Students.firstName equals duplicates.firstName. And students.lastName equals duplicates.lastName. And students.addresses.state. I might want to put middle names in there too. We'll see. Duplicates.state. And if I run this whole big thing, oh, I get another error. I did that on purpose. There's one little quick thing. This has nothing to do with aggregates, but having an order by clause in a subquery like this, SQL doesn't like that because it ignores it, because it's just treating this like a table. They're like, I don't care how you order it here. The only order that matters is going to be down here. So SQL could ignore this and just say, blah, I don't care. That makes no sense. But I think Microsoft has made the design decision to say, okay, we're going to say it's invalid because we don't want you to think that we're going to do something that we're not going to do. So anyway, just the error message is pretty clear. The order by clause is invalid in views, inline functions, subqueries. That's what this is. So I'm just going to get rid of that. Run it now. As you recall, I only had this one duplicate record running this part, Brandon Johnson in California. If I run this whole big thing, I've got 2 Brandon Johnsons, 499-9186. Yes, they do indeed both live in California, but one lives in San Diego and one lives in San Francisco. Let's pull birth date in there, see what their birth dates are. Students. .dob. And look at that, they've got different birthdays. So that's a different Brandon Johnson. False positive there, but again, this is how you would go about finding duplicate records in your database. Does that make any sense there? It's, again, something you're going to have to play with if you want it to really, really make sense. But I am going to erase this now. I have something very similar in my notes, so not to worry. And I'm going to go over a couple of useful examples, a couple of different ones. So I've got a couple more tables that I haven't spent too much time on in my fake database. Courses. These are all of my courses by year, by term, etc. And then I've got enrollments, which tie my students with my courses. So which student is tied to which course, etc. So I can make some interesting queries here, and this starts to look like things that actual end users are going to ask you for. So I'm going to go ahead and type this out. What I want to do is say, give me the number of courses that each student in my students table has enrolled in over their lifetime at this school. So select students. And I'm showing you this partly just so that you see more examples of the syntax, but also because I want you to just be aware that these questions will come to you if you're doing SQL for work, and this is how you solve them. So even if you don't catch all of this right now, I just want to at least put this in your head, how to solve these sorts of problems. So I'm asking for the student ID, the first name, the last name, and then the count. And so I'm going to say from students, join enrollments on students dot student ID equals enrollments dot enrollment ID, and then I'm going to join that to courses on enrollments dot course ID equals courses dot course ID. Okay, that should be it. Oh yeah, what am I missing here?
You have to group it, don't you?
Yep, thank you. Group by students dot student ID, and basically I have to group by, again, every non-aggregate thing that I make, that I ask for in the select list. So I'll just copy paste these all. Get rid of that last comma there. And let's order it. Order by count descending. That's interesting. Did I do that right? Let's cheat. Find it here. See, I even have, if you read these notes, you'll see that I even give myself prompts for what to say. Oh, it's just enrollments, I think. Let's take this off here. Just student enrollments. I don't even need the course information. Come on. What's different here? This is also why I plan ahead. That looks the same. Yeah, interesting. If I order by yeah, there we go. So there is a difference. Haha, that's it. Look at that. Join students.studentsid on enrollments.enrollmentid. I do that all the time. Students.studentid equals enrollments.studentid. The one difference that used to take me hours of troubleshooting sometimes on big queries. Just one little dumb mistake like that. So now I can see that Sharon Long, in the course of her lifetime at my university, has enrolled in 206 courses. I can get similar data if I want to break it down by year and term by saying, now I got to bring courses into the mix. Courses dot course year, courses dot course term. Now to make this work, need another comma there. To make this work, I need to join to courses on enrollments.courseid equals courses.courseid. And I need to group by these two things in addition to what I'm already grouping by. And the rest is the same. So now, instead of over their lifetime, I'm saying by term. So Mary Kay in fall of 2006, let's say, was enrolled in 18 courses. That's ridiculous. I'd probably want to reach out to Maureen Carey, maybe earlier, and tell her to ease up on her course load. This isn't good data. But if you ran this query on good data, you would have some good insight into who's enrolled into what. Let's go ahead and just make a new query here. So now I've asked for, give me all of my students and the number of courses they've been enrolled in, either over their lifetime or broken up by year and term. Let's flip that on its head and say, give me the number of enrollments by course. So select courses.course code, courses.course name, count star, num of enrollments from courses, join enrollments on courses.courseid equals enrollments.courseid. And another group by. Just copy paste all these guys. And then an order by, just to see the top. So now, and this is not broken up by term, but over the lifetime of that course existing, college math for non-science majors, as long as it has existed, it's had almost 5,000 enrollments. The final thing, just because people ask for this sort of thing, give me the top 10 most popular courses ever at the university. Top 10. Bam. There you go. Done. All right. And then just for fun, I'm going to take, sorry, that was a small font. There it is. I should have embiggened the font there for you. But it is also in my notes as well. So just for fun, just so you see some more stuff, I have shown you count, min, and max. I've been very count heavy. I'm just going to show you average. So let's take this This is the number of courses enrolled over a student's lifetime. Let's turn this into a subquery, put some parentheses around it, get rid of the order by, and we will call this student course enrollments. Now we are pretending that this query here is actually just a table. So I'm going to say select average, AVG, another keyword, just like count, min, and max, number of courses enrolled. That's basically this count here. From here, and now I'm going to look at all of these courses enrolled, number by student, run this query. And so students, this is an over the lifetime, but students over their lifetime have been enrolled in an average of 15 courses. Maybe that's interesting, maybe it's not, but you have this nice easy average button that you can use instead of doing that all by hand. And now the final thing that I want to cover today is sum. So I've counted records, but I've not added records yet. And as I was preparing this last night, I realized, oh no, I've got students, I've got courses, I've got, what else do I have? Addresses, enrollments. I don't have any like accounting type data, payment data. That's where you'd want to use sum, because counting counts sums. So let's make a new query. So in my desperation, I said, oh, there's this sample database called the Northwind database. Let's run a query on there. So I've got a couple tables here, star from order details. And so I've got this table here in this fake database. This is just a good place to practice as well, where I've got orders, what product was ordered, what the unit price was, and then what the quantity was ordered, and then the discount. So playing around a little bit, I looked at the products table, select star from products. So I've got all the products, and in my products table I've got a product ID, and in my order details table I've got a product ID. So let's give myself a basic report of all of the products that have been ordered and what the final price of that order was, taking all the products, adding them all together, all that sort of stuff, taking into account the quantity of products ordered, the discount amount, and this took me a while to think about because I can't do math at 8:30 at night, but I'm just going to use this. So I'm going to get the product code, the product name, and then sum. And this works just like count, min, max, average. It is an aggregate function. So I'll say orders.unit price. I could just do times 1 times quantity, orders.quantity. But instead, I'm going to go all out and take the discount into effect. From products, join order details. Let's just call it orders so it's easier to talk about. As you can see, I've given this table an alias, call it orders. On products.product ID equals orders.product ID. Group by products.product ID. And, where am I? I need a comma there. Oh, yeah. Products. That's my problem. I need one more item in my group by, which is the product name. Because again, the rule is all of your non-aggregate fields have to go into the group by clause. Let's order that, group it, run it. Now I have every order, what the product was, and the total. And I can play around with formatting of this and all that good stuff, but eventually, you're going to bring it into like reporting services or Excel or wherever, and you can do all your formatting there. So now I have a total here. That's the principles behind using sum are the same as the principles behind using min, max, average. Let's make this bigger. Sorry about that. Keep forgetting. The principles behind using all of these aggregate functions are the same across the board. And there are even more, which you can Google. But I've covered the top ones. Really, in my day-to-day environment, I use count constantly. Probably 85% of the queries that I write have count in them. Smaller percentage use sum, and then a much, much smaller percentage use things like average and min and max. But it's all useful stuff. And all you really have to remember is to know what you're grouping by. And remember the difference in the, where is my having clause? Rats. Okay, here we go. And where versus having. And that is everything about aggregates. Any questions? All right. Well, chew on this. I didn't come up with any homework per se, but if we look at SQL Zoo that we've been using, not that one, sorry. All my past homework assignments have you going on here and going through a bunch of these. And I've done most of these, but if you look at sum and count here, you've got some tutorials that say, okay, here's some sample data. Run the sum, so the sum of the population in the world. And then it brings into effect, grouping, counting, all of that good stuff. And in all of these, you can go to the reference, do something like select continent and count, group by world. So it's basically a count of all the countries in each continent. So if you want to play with this some more, and I encourage it, use either the production database that you have access to, test or production, use this site, or use the fake data that I have made up and that at least Sudan and Javed are using now. And that is all. Thank you all for calling in.
Thank you.
Thank you.
Thank you. Bye.
Bye.